Okay, we're going to begin Unit 3, and in Unit 3 Part 1 we're going to be talking about relations and functions, but there are some prerequisite information that we need to have before we get into the heart of relations and functions. So we're going to begin with those targets, and the first one is using graphs to relate two quantities. So we're just going to go through some examples here, being able to pick out the variables, analyze the graphs, maybe even draw some graphs. So let's start with problem 1. We're going to analyze the situation that's been illustrated here in this graph. Now it tells us the graph shows the volume of air in a balloon as you blow it up until it pops. So the first thing they ask us to do when we're analyzing this graph is to determine what the variables are in this picture. Well, when you look at your picture, variables, think about x's and y's, thinking about this is your first quadrant, this is your x-axis, this is your y-axis. The two things that we are discussing here is time as it relates to volume. So our variables are time and volume. Now, what they want us to do with these variables is actually analyze and describe what's going on in this graph as those two relate to each other. And it talks about at various points on the graph. So we're just going to discuss different times, different things that's going on within our graph. So let's think about if we actually had a balloon in our hand and we were going to blow it up with air. The volume is at 0. We haven't blown any air into the balloon yet, and our time has not started because we still have not started blowing the balloon up. So as we take the first puff, we blow into the balloon, the volume of the air is going to increase as well as the time is continuing, and time is continuous, so it's always going to be moving forwards no matter what you're doing. So the first part of this graph, we're blowing the balloon up and the volume is increasing. But then we have this flat line. So we need to think about, what does this indicate? Well, think about if you were actually blowing up a balloon and you start blowing into the balloon, at some point you're going to run out of air, so you're going to have to pause and take a breath and then start blowing again. Well, as you're blowing up the balloon, air is going into the balloon. When you pause to take that breath, assuming that you pinch the end of the balloon and it doesn't lose any air, it's not gaining any air either. So time is still continuing. So we have a flat line here where time is going on, but the volume of the air of the balloon is not increasing. And so that would be the first time we started blowing into the balloon. We took a deep breath, and then this hill here would represent the second time we were blowing into the balloon. And then again we had to take another breath, so our flat line. So this hill represents the third time we took a breath, or we started blowing into the balloon. Again, we had to stop for air, so we have a pause here where we are breathing. And then the fourth time is this very small hill, because at this point it pops. And that's what they told us in the problem, that it's going to pop. So you didn't make it very far into blowing into the balloon the fourth time until it popped. And when the balloon popped, it lost all of its air very quickly. So what we need to do, we've discussed it, we've kind of looked at it, and I've illustrated a few things in here, but we need to actually describe what's going on in this illustration. So I'm just going to make a couple little bullet points here. The first one, we'll just write some information. The volume increases as you blow air into the balloon. Now we're just writing basically what we discussed when we were looking at this picture. So the volume increases as you blow air into the balloon. And we can call those flat lines, and I'm going to put them in italics because That's just trying to describe parts of this figure, and just to kind of illustrate what we're talking about or point out in our picture what we're discussing. The flat lines in our illustration are the pauses. Remember we talked about we have to pause to take a breath before we can start blowing into the balloon again. Are the pauses when you are taking a breath. So we've got the volume increases as we blow air into the balloon. The flat lines are the pauses when you are taking a breath. And then the last thing that we discussed, the balloon pops on the fourth blow. And we talked about how it decreases very drastically on that fourth blow. So when the balloon pops on the fourth blow, or the balloon pops on the fourth blow and loses air, we'll say quickly. Just in your own words, and you may write this completely different than the way I did, but in your own words you need to be able to describe what's going on in this picture. How is time relating to volume, and what do all of these hills and flat lines and this drastic drop, what does all this mean? So that's what we're trying to do, is just being able to analyze graphs and describe what's going on during various points on the graph. So I want you to take this, you've got two your turn problems here. Your turn problem 1A, we're talking about board length. And so I want you to what are the variables in this graph, and describe the variables and how they relate, just like we did in the last one. And then this one, B, June cell phone cost. So how much is it costing you just in the month of June for your cell phone? So very short, doesn't have to be very lengthy. You can also bullet point like we did on the last one, but describe these two graphs. Alright, so that was problem 1. We're going to look at problem 2 now, and this is actually a multiple choice question. We're going to match this table to a graph. So a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? So A, B, C, or D, which one of these could represent what we have in this table? So what we need to decide, we need to look at making sure we have the two variables necessary. We are talking about days and total downloads, and each one of these we are talking about day. And days, time usually continues on, well, it always continues on, but it's usually your x-axis, because it does represent how it's going to continue. It's never going to go in reverse or back up. You can't rewind your day. But as far as your y-axis, you could have increases and decreases over time. So time again will continue on, and total downloads, if we look at our table, they are increasing. Okay, so I haven't looked at anything, I haven't tried to figure out how quickly or slowly they're increasing, but I can tell that more people are downloading this video. So if I look at my illustrations here, I can see that D is actually decreasing. It's showing that over so many days, the number of downloads is going down, and that's not the case in our table. So we can immediately eliminate D. Alright, so let's start kind of analyzing what's going on. We can tell that our days are going up one at a time. That one's pretty simple. But we want to compare what's happening from day 1 to day 2. What's the difference in the number of downloads in day 2 compared to day 1? In difference, we talk about subtraction. What is the change here in those two. And so to find the change, you're just going to simply subtract. Now, you could, if you add those, you're going to get a total amount of downloads for day 1 and day 2. So be very careful. Don't try to add those. And it can help some, but it's not going to actually help you identify how these dots, when you place these on your graph, how should they be increasing. This one seems to be increasing the same amount each time. This one seems to be increasing at a different rate, but very quickly. This one seems to be increasing at different rates, but seems to be getting closer and closer together. So it seems like not at each day is increasing, but not by very much. So that's what we've got to analyze here, and that's why subtracting these and determining what's the difference in these two, how is that going to help us. So from 346 on day 1 to 1011 on day 2, there's a 665 download difference between those two. So then we need to find the difference in day 2 to day 3. So if I subtract 3,455 from if I subtract 1,011 from 3,455, I get 2,444. So quite a big jump from day 1 to 2, and then from day 2 to 3. So let's do the same thing here. Let's figure out from day 3 to 4, let's subtract 3,455 from 10,426, and we're going to get 6,971. So as you can see, we're not increasing the same amount every day. Okay, we had 665 difference from day 1 to day 2, and then 2,444 from day 2 to day 3. So it's increasing quite drastically each day. So we definitely know it's not A. Again, A is increasing at a steady amount every time. The ones we have to decide between, which are usually the two most difficult, are B and C. So think again about the difference. This one, we started off at a low amount. We increased quite a bit. We increased quite a bit more. Then we increased even more. You can see the gaps in between are getting much larger from in between each day. In C, we started out at a high amount, and we increased quite a bit, but then we increased just a little bit more, and then just a little bit more. The gaps from dot to dot moving up are getting a lot closer together than they are here. So this is indicating that we sold quite a bit on day 1. Day 2 we sold more. On day 3 we sold a little bit more, and on day 4 even less. We still sold more, but not very much. So this one is definitely not our choice because we are increasing very quickly. So our graph that matches our table is B. So being able to look at your table, identify the change. How is my Y value changing? How drastically is it changing, or is it constant? That sort of thing. And then being able to match your graph to that table. So let's take what you've learned here in problem 2. I want you to apply that to your turn problem here. Same basic process, just analyze what's going on in your graph or your table and determine which graph could represent that data. We've got 3 choices here, A, B, and C. So you've got the number of uses of sunscreen and then the amount of sunscreen in ounces that's being used. All right, last problem we're going to look at is problem 3. And problem 3 actually gets us into sketching our own graphs. Now, when you're sketching your graph, sometimes you'll be given X and Y axes. Sometimes you are just given a blank sheet here. In this case, we have a blank sheet, so you have to build your own graph. So either way, make sure that you always label everything. Now, we're also going to label each section of our graph, but you need to make sure you label your X and Y axis, and that way it indicates what your variables are that you're using in your problem. So let's read through this problem. We have a model rocket, and it rises quickly. Now, since I know I'm going to be sketching this graph, I want to think about all the parts of the graph that I need to have in my picture. So my model rocket is going to rise quickly and then slows to a stop. So it's going up very, very quickly, and then it comes to a complete stop because it runs out of fuel. Now keep in mind it's in the air still as it rises very quickly and it comes to a stop in the air. So then it begins to fall quickly until the parachute opens. So if you think about this, think about it visually. If you set off a rocket, it's going up very, very quickly, and then it slows to a stop, complete stop in the air, and then it's going to start falling back to Earth very quickly until the parachute opens. Now when the parachute opens, that's going to slow the fall. It's still going to fall to the Earth, but it's going to fall slowly back to Earth. So we got to figure out what sketch would represent the height of this rocket during its flight. Okay, so we want the sketch that represents the height during its flight. Now height, okay, we're talking about going up, stopping, coming back down, but during its flight is indicating time. Over time, how high does this rocket get, and what's it look like when it starts falling back to Earth? And then we need to make sure we label each section. So our variables are going to be height of the rocket and time. And again, whenever you're creating your own graph, we talked about this in the last problem, time is continuous. It's always going to be moving forward. However, things like height, weight, that sort of thing can fluctuate up and back down, and in this case it is, because we know that it was going to rise quickly, then stop, then start falling again. So our x-axis is going to be time, and our y-axis is going to be height. And this is our y-axis. So now we just need to start sketching. We don't have any points to plot. We just need to draw what this illustration would look like. So at 0, 0, when the height is 0 and time is 0, we are just about to launch this rocket. It's on the ground, and we have not started our timer. But then it's going to rise quickly. All right, so let's think about our rocket. It's going to go up, 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 up. But then it slows to a stop. So it's going to get to a point where it starts slowing down and then stops. So let's mark this first. Let's label each section. This is where it rises quickly. But then at one point it's going to run out of fuel. And this is where it's going to stop. That's where it ran out of fuel. All right? It begins to fall quickly until the parachute opens. So we've stopped. Now we're falling back to Earth very quickly. So this is right here, falling quickly. However, notice that I stopped because it doesn't fall all the way back to the Earth. It just falls very quickly until my parachute opens. So at this point right here, the parachute opens. Now it's still falling, but after the parachute opens, it's going to fall at a pretty steady rate. And so this is falling slowly. I didn't draw my x-axis out far enough, but this is just a good rough sketch, and you could clean this up after you've got a rough sketch. It might be a good idea to clean it up and redraw it to make it look nicer, but this indicates that we launched the rocket, it rose very quickly, ran out of fuel and stopped, and then started falling back to Earth very quickly. However, the parachute opened, and that caused it to float or fall softly and slowly back down to the Earth. And this would need to, if we extend our X and Y axis, or just the X axis here, this would need to fall all the way back to the X axis to show that it does reach the ground again. It started on the ground and it lands on the ground. So sketching a graph. So I want you to sketch this graph in the Your Turn Problem 3. You're going to start swinging yourself on a playground swing. You move back and forth and swing higher in the air. So think about swinging, what it looks like when you're swinging back and forth, and you keep getting higher and higher. So put yourself in the situation if you were on a swing. Then you slowly swing to a stop. So eventually you're going to stop. So you're getting higher and higher, but then you've got to slow back down and get lower and lower and eventually stop. So what kind of sketch of a graph could you draw that would illustrate your height from the ground over time? And make sure you label each section. Alright, that concludes Learning Target 1. So I want you to go through these 3 summary questions. Look at number 1 wants to know the variables in the graph and describe them, so it's like our problem 1 we did. Number 2, describe the relationship between time and temperature in the table. You're not making a graph, but just explain what's happening between time and temperature. And then 3, match one of the labeled segments in the graph below with each of the following verbal descriptions. You've got rising slowly, constant, and falling quickly. So you want to know which one of these matches each of these descriptions. And that concludes Learning Target 1 in Relations and Functions, the Prerequisites.